discover a new photographer to work with you on this water piece. Copy deadline Thursday 7 p.m. All right, see you then. Thanks, bye.
Thanks, Bill. 2 days to finish a lead feature, and who do you send me? The new boy.
Carol?
Yes.
I'm Paul. Bill sent me.
Ah, come in, please.
Thank you.
Would you like a cup of tea?
Oh, that's very kind. Thanks very much.
So you're new with the paper, then?
I used to be in sport. Thought it was time I got into the first division.
So you had a transfer?
Yes. I read your piece on solar energy last week. It was very good.
Thank you.
Yes, you make it sound all so simple.
Yes, there's a knack with that, I must say. I don't give all the scientific facts. I try to give people what I think they want to know, which is how things affect their lives. And it's going to be exactly the same with this piece we're doing on the water cycle.
You and I are working in tandem.
A cup of tea, then, before we set off. Do you think it's going to rain today, Paul?
I don't think so. Light's pretty good.
It's funny, isn't it, how we moan on and on about the weather in Britain, but really it's a godsend because our lives depend upon rain, after all. And in the Thames water region, they have 700 millimetres of rain every year. That's about 21 inches. Or in terms of pints of beer, that's 1,000,000 pints.
I mean, even the sports desk would have a job getting through that lot.
Yeah, I think they would. And we totally rely on nature for it, because what happens is that the water evaporates from the rivers and the seas and the lakes and goes up into the atmosphere. And then at a certain temperature, when it's cooled down just enough, it turns into clouds. And then the clouds float along in the air currents, and then eventually, when they cool down...
Don't tell me. Then it rains.
Yes, it does. But what happens to it after it's watered all the crops and all our gardens? Well, apparently it either goes to fill up the rivers or it seeps through porous rock into what are known as aquifers, like underground reservoirs.
Oh, yes, that's where potholers go.
Well, that's a common misconception, because what aquifers really are sort of huge sponges made of rock, and they soak up the water, and that's how they act as a reservoir.
Oh.
Now, Joe, can I just check a few things through with you? Thames Water have 6 million customers who rely on them for water from their taps.
Actually, it's over 7 now.
7 million? Right. Now, they use about 450 million gallons of water every day. That's 2,700 megalitres. Now, most of it comes from the Thames, its tributaries and the River Lee. And Thames Water is licensed by the National Rivers Authority to take that water out. The rest of it comes from boreholes and from wells.
It's a wonder the rivers don't dry up.
Well, they would do. Except we're restricted on how much water we can take out each day.
Ah, so if it's a long, hot, dry summer, I can see why you ask everyone to go easy on the water from the taps.
Yeah, so we don't end up high and dry.
Now, the water from the rivers is pumped into a reservoir like this, and you do encourage people, don't you, to make use of them?
Very much so. Thames Water actively encourages recreation like fishing and sailing on its reservoirs. It also conserves wildlife around all its sites.
Now, the river water that's been stored in the reservoir then comes here to be treated.
That's right. Although if it was groundwater, it would only need minimal treatment.
But really, the treatment starts in the reservoir, doesn't it? Because you allow the larger particles of river silt to settle to the bottom first. And then, before it all goes into the treatment works, you push it through screens which block out the large objects like fish and wood, and then through micro-strainers which take out some of the algae.
It's all quite simple then.
Yes. So, Joe, am I right in saying that if you think of a mountain spring, that water originally falls as rain and then filters its way down through layers of sandstone rock to purify it naturally? Is that the same principle that operates at the treatment works?
That's right, but on a much larger scale.
They couldn't rely on mountain springs and underground caverns to purify enough water for 7 million thirsty customers, so they had to devise their own filtration system. At most works, including the large ones in London, the water goes firstly through coarse sand filtration to remove larger particles, and secondly, through fine sand to remove the smaller ones. However, at a few of the works, chemicals are added to coagulate or join together the very fine silt particles to make them large enough to settle in a clarifier tank. And then this settled water is filtered through fine sand to remove any of the smaller particles.
Ah, but how do you know it's still fresh by the time it gets to my house?
Well, the water finally has to be disinfected to maintain purity, and they do that by adding chlorine. Carefully regulated, of course. Now that's added in a contact tank, and it takes about an hour for it to make the bacteria harmless. Then sulfur dioxide is added to remove most of the chlorine. But they have to make sure that all the chemical levels are monitored very closely to give maximum safety and, of course, maximum benefit. And just recently, Paul, extra stages of purification have been planned in the Thames region. The pilot scheme for this, at Kempton, prepares the way for all Thames Water's 7 million customers to benefit from an even better quality water, exceeding European Community standards. And here, the water is filtered through granular activated carbon, which is a bit like charcoal, and that improves the taste and the odour and extracts any pesticides which might be present. It's already being used at some smaller works.
Thanks, Carol.
John, now it is 200,000 samples of water that you're testing every year, isn't it?
Yes, it is, and that means 1.5 million analyses. And in order to do that, we have the best equipment in the world here.
Shetlands Avenue, that's my mum's street. You mean they actually go to individual houses to test the water?
Yes, they do.
Yeah, literally around the houses. The pubs, the offices, the restaurants. In fact, virtually everywhere you'd want to go to get a drink.
The White Hart, Edmonton. That brings back a few memories.
Yes, I'm sure it does. Now, as I was saying, you test the water through every single stage, from the reservoirs and the boreholes through the complete filtration system, even as far as the kitchen sink.
You certainly get around, John.
Yes, that's 30,000 kilometres of distribution pipe.
Really? What's that in feet, Carol?
That's 30... It's a lot.
You know, Carol, I've always had a thing about women in hard hats.
You keep taking the photos and leave the lines to me.
Like the Circle line down here.
That's exactly what it will be. A subterranean fresh waterway looping its way entirely around London.
A sort of underground M25.
Yes, I suppose so. It's the London Water Ring Main. By 1996, this will supply half of London's drinking water needs. And Thames Water have invested £250 million in it. But the system itself is unique because it's gravity-fed. It's actually the first of its kind in the world.
Yes, longer than the Channel Tunnel, deeper than the deepest tube line, and able to shift 285 million gallons of water a day. That's enough to fill the Albert Hall 8 times over.
How do you know all that?
I sort of, just picked it up. So each of us gets through 28 gallons of water a day. That's a lot of cups of tea.
Yes, apparently 18 gallons of water go down the plug hole every time you have a bath.
Well, I'm all in favour of bathing with a friend.
You'd have to find one first. It takes 22 gallons from a machine load of washing, and apparently it could take 200 gallons an hour if you want to sprinkle the garden in the summer. And 2 gallons every time you flush the loo. Which brings us to the end of the story, sewage treatment. We're going to go down a sewer next.
Is that the time? I really must get down to the lab to pick up my prints.
Oh, no, you don't. It's all part of the water cycle. Shall we go?
Go easy on the water, mate.
This is where London sewerage started 150 years ago, right down here. Amazing. But before that time, London was just an open sewer. And then in 1858, they had what's known as the Big Stink. And not surprisingly, pretty soon after, they started to build vast underground channels like this one. Of course, things have got a lot bigger since then, and nowadays Thames Water manages over 50,000 kilometres of sewer pipes. That's more than the circumference of the Earth.
Oh, well, another shot down the drain, as they say.
Well, this system takes the whole lot. It takes water from the roads, industrial waste and domestic waste. They're not split up at all. So, everything that goes down the drain, and that's from 5.25 million premises in their region, well, it all goes on to the next stage, to one of the treatment works. And there are 400 of those. It's quite incredible when you think about it.
Yes, I try not to.
And this is where it all comes into. I'll see you in a couple of minutes.
And I thought it would be all glamour in features.
Now, the sewage which comes into the treatment works is usually 99% water. All the solids are removed by screens, or they're cut up by what are known as macerators. Then the sewage flows gently through grit settlement channels into sedimentation tanks, and all the debris settles as, well, as sludge. Now, the organic sludge goes into digestion tanks, where what's known as anaerobic bacteria breaks it down into methane and other compounds. And they are used in recycling, because these gases are put through electricity generators to produce power to drive the plant. But what happens to the sludge after that? Well, some of it is put out to sea, but most of it is used as a fertiliser and a soil conditioner. The leftover water, that's the effluent, then goes into aeration tanks, where bacteria breaks down the pollutants which are left. Now, that type of breakdown can also be done by running the effluent through percolating filters. And this is usually done in small rural sewage works, oh, like this one. Then the water is passed through yet more sedimentation tanks and sand filter beds so that it meets with European Community discharge standards. And finally, the cleaned water flows back into a river. Right. That's it. Copy's gone. Bill should get it later this evening.
Great.
Simple, isn't it, this water cycle?
Piece of cake. So Thames is the biggest water company in the country?
Yes, with over 11 million customers in a 5,000 square mile region.
I know, I've read the fact sheet. We get through 450 million gallons of drinking water a day.
Yes, and Thames Water are due to take the standards even higher than those laid down by the European Community Drinking Water Directive.
I suppose we take it all for granted, really.
And if you look in there, you'll see that they dispose of over 1,000 million gallons of sewage and water every day.
I mean, spending a lot of pennies.
Yes, and they're due to spend £1 million a day for the next 10 years to take us into the 21st century with some of the highest drinking water standards in the world.
You've got to hand it to them.
Yeah.
Carol? Bill. Got the copy and the pictures? Great. You obviously hit it off together. I'm sending you off now to cover a piece on water contamination along the Nile. It's right up your street, I think, after the water cycle. Talk to you later. Bye.
Best discuss it over a nice cup of tea.